Welcome to our session. We're going to talk today about WebAssembly, about Linux, about Codespaces, about dev containers. So we really felt like we need to do something different this year. AI is nice, but not too keen on the 115th AI demo, to be honest. Maybe we've seen enough Power Platform as well, so we felt like let's do something completely different. I was a bit worried that we would be sitting in front of 10 people because no one would get the idea, but I'm very happy to see that all of you have joined, even on 9 on the second day, so thanks a lot for coming. With that, I also want to say thank you to Stefan for joining the stage today, but please, Stefan, introduce yourself.
Yeah, as you can read, my name is Stefan Maron. Currently, I'm a freelance BC developer, and you might have heard some of my projects. So I was the creator of the code history repository on GitHub, as well as the linter cop. Feel free to reach out to me on Twitter, LinkedIn, GitHub, anywhere, if you have any questions afterwards. And I'm going to show you later another VS Code extension I created.
Perfect. Thanks. So to introduce myself, Tobias Fenster. On the business side, I'm a managing partner at 4PS in Germany. On the community side, I'm an MVP, a regional director, and a Docker captain. And if you want to reach me, you can find my social handles, my blog, my podcast, and so on. So yeah, always happy to have discussions on BC tech, around BC, with BC, whatever. So please feel free to reach out. But with that, let's dive right into our topic. I first want to let you know that a lot of the things that we are showing today are more or less experimental or are relying on implementation details that we figured out by looking at code that might change tomorrow. So I sincerely hope that all of our demos work, so I can prove to you that it works today, but it might not work anymore tomorrow. So if you want to use the things that we're showing today, especially the stuff that Stefan will be showing, he's using on a day-to-day basis, so we are pretty sure that it's quite stable. On the other side, there might be changes coming up soon, so yeah. If you want to use it, feel absolutely free, but be aware that this is stuff that might break without further notice. But I hope it's fun and could give you an idea of what will happen in the future in our ecosystem. And if you don't know who that guy is, then that shows that I'm pretty old and you're probably younger. And if you start Googling, it's 3 movies. First is great, second is okay, the third don't even bother if you haven't seen it. Okay, so let's go into the actual topic. What are we going to talk about? First part will be about WebAssembly or Wasm. What is it? Where does it come from? Why does it matter in general? Why does it matter for us in the BC ecosystem? And of course, we're going to take a look at a couple of demos. And then in the second part, we're going to take a look at Linux, dev containers, and Codespaces. Again, why would you bother to implement or to use AL on Linux, and how does it work? Dev containers and Codespaces, again, why does it matter? How does it work? And let's see a couple of demos. In the end, depending on how much time we have and how much questions you guys have, we're going to take a look at the AL language Linux patcher, which you probably don't know yet, but will get to know during the session. So let's see if we have time for that. And if not, then Stefan will find a way to share it anyway. So what is WebAssembly or Wasm in short? Basically, it's a safe and portable low-level code format. The idea of WebAssembly is that you can get with something that is actually platform agnostic, near native performance in a sandbox environment. That means that the code that you create, that you compile into Wasm, is running in a secure environment that is completely independent of the hardware, of the platform, of the language, and so on. So we're going to be using a couple of different languages, programming languages today, but it all will be Wasm in the first part. It gives you a very small and efficiently executable file that you can use to stream and parallelize. So you don't have to have all the code to start executing. You actually can have small parts first, start executing, and then later download the rest of it. And it's a modular and a binary format, which means that you can plug in different modules collected from different places that can talk to each other. It's an open standard. I've put the link here if you really want to, if you have trouble falling asleep, then a standard is always a good idea. So you might want to take a look at that. The first implementation of browsers, and we'll also start there in a second, have been in browsers because, of course, You have a safe way to execute code without accessing something outside of your code. It's portable, it's small, it's efficient, it's streamable. I think it's pretty clear that this is something that makes a ton of sense in a browser, in web applications, but we'll also take a look at different implementations. And the example, and that's where I want to start first, is banana bread. So this is actually a WebAssembly implementation, and I'm extremely bad at it. So there will be a guy soon who will hurt me. Let's see where. I can jump, I can shoot, I can run. And there he is. And I will have a problem because I'm extremely bad and I don't even have a mouse. But anyway, let's stop that one right here. Point is, this was a WebAssembly application built in 2012. I was actually surprised when I started to dig into the origins of WebAssembly, how soon it started and how much you could already do in 2012 at that time. Of course, gaming is always an interesting application because it has its complexities, it has performance requirements, but there are other implementation you might have seen in the past couple of years, things like Photoshop, Figma, AutoCAD, really have big requirements, graphics requirements suddenly run in the web, and the reason for that is WebAssembly. Same is true for Google Earth. So whether you know it or not, you have probably been using WebAssembly quite some times in the past. How do you actually create something that could run as a Wasm thing, as a Wasm module? Well, it depends on where you're coming from, where you want to create your code. We have first system programming languages like C, C++, Rust, and Go, and they have always been used to compiling into different formats because they needed to target Linux, they needed to target Windows, they needed to target different architectures like ARM and so on. So for those kind of languages, it was relatively easy to create support for Wasm because they just needed to compile in a different format. So they already had things in place that made it quite easy for them, and therefore they were faster. Then bytecode languages like Java or C#, for them it was more difficult because they were already compiling into their own intermediate languages, but they weren't used to compiling into different targets, basically. So that made it more complicated for them, took a bit longer, and you still see languages picking up support for Wasm. Mostly it's still experimental, early days, and so on, but you can use those languages to create Wasm components already. And then for scripting languages like Python or JavaScript, they just have an interpreter because you just write the script and then it's interpreted on the fly. And what they are typically doing is that they are porting the interpreter to Wasm, so you still have your scripts. The interpreter is running on Wasm now, and the scripts are interpreted. From a support standpoint, it can run in all major browsers, but you can also run them natively on Linux, on Windows, on whatever you need. But because the Wasm module itself doesn't know what to do, it's just the instructions basically, you need a runtime. The runtime could be a browser, or it could be something that is running on your machine, somewhere in the cloud, whatever. And that's where the WebAssembly system interface called WASI comes in, because it allows a WebAssembly component to have access to the system, to have access to networking, to files, and so on. That's it for the theory. I thought about how much theory do I want to do, and I decided to keep it short. I hope you can still follow along, but let's dive right into our first demo, because we want to create something that is a Wasm module. What we're going to do is we're going to use Rust as programming language. We're going to create a hello world, because, that's what you do in development when you do the first demo. And then I'll show you how the security sandbox works, and I'll show you how portable it is. And because we have Codespaces as our second topic, of course, I'm using a Codespace for development. And I need a bit more space here. Actually, is that still big enough? Oh, okay. So what we're going to do, you can see here, Visual Studio Code. As I said, it's a Codespace, but you won't notice the difference for today, and what we're going to do is first create a demo project. And I would have had to delete the demo. Try again. Okay, that's better. So we have our brand new demo project. It has very easy code. It says hello world, and of course we're going to change that to hello BC TechDays. And that's basically all. So the most simple implementation that you can think of. Let's go into the demo folder, and now we're going to do the build, as you can see here. And it has a target that says Wasm Wasi, which means it's compiling a Wasm module that wants to target the system interface, so Wasi. And now we already have our module, and it's in here, target, we have a Wasm file. So this is a binary file, we can't take a look, but this is the module that I can take and run basically everywhere. So to show you, we're going to use the Wasm time implementation of the Wasi, and there you can see, okay, we have a hello BC TechDays, so exactly as we expect. And as I said, it's completely independent, so if I download this to my local machine, in the demos folder and overwrite the existing file, yes, then I can open my local machine and do a Wasm time demo Wasm, and it still works hello BC TechDays. So that's basically the idea, and one of the big benefits of Wasm. You run it or you create it in any language that you need that has support for Wasm, and then you can just distribute it to anywhere, and it will have a way to run. Now, to make it a bit more interesting and also show you the concepts of the security sandbox, and because I'm bad at typing, I've prepared it. So you can see here in Rust that we want to use the environment, we want to use the file system, we want to use read-write access. Second step is to create a little function that takes a file, as you can see here, reads the file, creates another file, and writes the content of the first file into the second file. So we're basically just copying two files. And then we need a main as well, and that one is just taking the arguments that it's giving it, running the program, and executing the copy. So again, let's compile. Try to run, and that says, okay, you need to give me the file that you want to copy and the target file. So let's first create the file. So we have our first file, and now we can say, and put it into another file, like this. And it says there's an error, and that's what I wanted to show you, because that is the sandboxing thing. So I can't just access a file because I have the code, I have the required libraries, I'm running in this sandbox, and that doesn't allow me to do any networking, to do any file access. It's completely secure. I can, of course, give it access. If I do something like this, it works. So if we now take a look at our file, you can see we have copied from one file to the other file. It has worked. And I could now copy this over to Windows again, do the same thing on Windows. It would just work, but for the sake of time, let's not go there. But just to give you an idea, this is how you create the applications, how you run the applications. We will also see later how it works in a browser, but in general, you create the Wasm module. That module has a starting point, has functions like you're used to in programming, and you can access them and do things with it. Let me check, did I forget something that I wanted to show you? No, this looks good. Okay, so this was the first demo. Why does this actually matter? Why does it make sense to look into Wasm? You can already see with the samples that I gave you that it's used widely all over the place to put all kinds of near-native code, near-native performance into a browser. So that for a very long time has been the main application of WebAssembly, that you want to run something that is actually native, that you want to distribute in a different way, and that needs almost native performance into a browser. Because it's so small, it's secure, it's portable, it's also very interesting for IoT and edge devices, because there you typically have very small resources. You need to be able to run something that's very small, very efficiently, and again, that is something that WebAssembly can do. It also allows you to use the right tool for the job, because as I said in the beginning, Wasm tools can easily interact with each other. So if you have something that you actually want to create in, let's say, C#, but it would like to use a Go library and a Python library, then this is something that with WebAssembly is relatively easy to implement. And what we've seen recently is that a lot of cloud service providers have started to support WebAssembly, or new cloud service providers have been created solely on the purpose of creating WebAssembly support, where you get a framework, where you get an environment that you can just throw your WebAssembly module at, and they take care of the rest. It's completely serverless runtimes with great performance, again, because of the benefits of WebAssembly. Why does it matter for us in the Business Central world? I think there are two clear scenarios with maybe less clear applications, and that's where the experimental part comes in. But the things that you can do in general is either you use it on the client side, so that means you have your web client open, you want to do something in there, and you use a Wasm module for that. That's going to be the first thing I'm going to show you, and then of course we have the server side. It's extremely fast, secure, and scalable, and maybe it can do things that BC is just not ideally equipped because of the way that AL works, and you just want to use whatever language, whatever library you need, and you can address it from Business Central, which basically means the service tier would call a WebAssembly application. And as I said, we're going to do a demo of both parts now. So the client-side demo is the idea that we have the nice little pictures of customers on the customer card. And what I want to do is I want to use a Go library to change that picture. So live in the browser, we're going to use JavaScript to address the WebAssembly module written in Go. That will get the picture, will change the picture, and show it again. So let's take a look if we can make that happen. My second code space is here. So what we have is our Go application first. It has a bit of code here. So it's using a library to adjust the image. We can do integrations with JavaScript. So you can see here that we have a brightness callback. So if we later change the brightness on the image, that's the code that will be called. It gets a number, which is the amount that we want to change the brightness. It uses the image library that you can see here to set the brightness, and then it sends the updated image back into our browser. And again, we're going to use JavaScript to make sure it works. Then we have the same for contrast, we have the same for hue, we have the same for saturation. So that's basically the core of it that actually does the changes to the image. Then we have some code that loads the actual image. So it takes the bytes of the image, puts them into a buffer, it resets the sliders. So this gives you an idea how we can also, from our Go module in WebAssembly, talk with the browser through JavaScript. So we have a brightness slider, we have a contrast slider, and so on, and we can reset them. And the last part is to put it all together. So we have our main method, and when it starts, it sets up the brightness callback on our brightness slider, it sets up the contrast callback, and so on. And in the end, it says hello from Wasm Go, and we will see that message in a second as well. So that's basically the Go part, and as we seen before, we need to compile it. And now we should see here, it's the Shimmer Wasm. So this is the Wasm module that we've generated, and of course now we want to use it in AL, we want to use it in Business Central. So for that, we're going to use a control add-in that you can see here. It uses the images as a workaround to get the Wasm module into the browser. It has a startup script. It has something that helps us to execute the Wasm module. That's a standard script that just comes with Go in this case. And we have an additional script here. To give you an idea, the startup just creates a bunch of HTML code. Again, we have our brightness slider, we have our contrast slider, and so on. We inject it into the into the HTML code. We have a status field that first says initializing. It loads the Wasm module, as you can see here. Maybe I should enable word wrap. Yeah, you can see here how we get the Wasm module. Then we instantiate it. We use our status field to say when the initialization is done, and we create a connection through this memory bytes array between the Go world and the JavaScript world, so we can pass the image back and forth. In the additional JS, you can see that we first have a connect image function that fetches the picture. So by looking at the area labels, I can figure out what the picture of the customer is, where it is, and then we just fetch it into a byte array and call the load image function that you've seen a second ago. And then on the other side, when it is changed, we have the display image function that again takes the area label to identify the customer picture and shows the changed image. And then on the page, extremely simple. Again, we just add the image adjust control that you've seen, and we have an action that runs the connect image function. So let's see if we can publish. And this is one of the drawbacks of running in a code space. We need to re-authenticate all the time, but that should do the trick. It's publishing, and we're getting Business Central.
But did that just demo AL in Codespaces already?
Yes, absolutely. And in a second, we will see why that actually works. So we have our customer picture here, slightly adjusted from the standard. And now I can, you see here the hello from Wasm Go. So we know that the implementation has worked. This is actually Go code that has created that message. Now I can connect the image. It says ready for operations. And now I can adjust the brightness. I can adjust the hue. So yeah, absolutely business critical application, I know. But still it was fun to create. If I move over here, I can again connect the image, adjust the hue, adjust the saturation, and now we have a beautiful black and white image. So again, I know it doesn't absolutely make sense, but it shows you that there is a way how you can use a completely different programming language, a completely different approach to create a Wasm module, connect it to your Business Central code, AL, control add-in, and use that to make whatever you might need to make in your application. So this is basically the client side when we actually run the Wasm module in the client. But as I said, there's also an application on the server side. The idea here would be that we have a backend service on open page. So whenever a page is opened, we call a backend service. And because Wasm is so incredibly fast and scalable, it doesn't take a lot of time. Now, this is certainly not something you should do a lot because it will make opening your page a bit slower. But I hope that you will see in a second that it's actually quite fast. What we will use is one of those serverless providers that I talked about called Fermi & Spin. They provide a framework for building and running microservice applications with WebAssembly, and I'll show you in a second how that works. Basically, they just give you a framework that you can use to create your Wasm applications, and B, a runtime, so we can just publish into their backend and it works easily. We will see how we can create a module, we can see how the performance is, and then in the end we will take a look at the pre-built example with the BC integration. Again, let's switch to a code space. And get a terminal. Let's say spin new, which is the way how we create a new spin module. It will be an HTTP Go implementation. The name will be BC TechDays demo. No description, just accept the defaults. And with that, we have our BC TechDays demo application. We see here, now we switch to Go. We have a handler that just takes a request and answers with hello Fermion. And of course, we're going to change that to hello BC TechDays. And that's basically all it does. The main function is empty. So when we now do a spin build, that takes a second, so I also want to show you the second important file, which is the spin toml. There you can see that for all of those different components, and we are now creating the main Wasm file, so that's where we're running. I can say which HTTP hosts, for example, are allowed to, I'm allowed to reach out. So another example of the security sandbox, I need to explicitly state which backend URLs I want to access. So if my Wasm module wants to reach out, that needs to be in that list here as well. So we are done building. Let's do a spin up, which means that the application is running and we can connect to it. Yay! Let's see if it works locally. We are not getting an answer. Why not? Let's try again. I think I've run into an issue on GitHub. Let's try the curl again. Okay, what I actually wanted to show you is that it initially works, but maybe last attempt to show you. If we just create the GET request here, we get a response of not found. Did I run it in the right folder? No, I didn't. Okay, sorry. Our demo is BC TechDays demo, and if I do a spin up here, I need to first compile it, because I also did that in the wrong folder. So let's oh, I did it in the completely wrong folder. Now I see. Okay, sorry for that. So let's move it into the right place. Okay, let's see if it works here. Spin build again. I knew one of the demos was going to break, but I thought it would break because they changed something in the backend. But this is clearly my own stupidity that breaks it. So sorry for that. Spin up again. Try to access it. Hey, hello BC TechDays. So that has worked. The request here also works, hello BC TechDays. Okay, that's what I actually wanted to show you. And the other thing I wanted to show you is the performance. For that, I'm going to use a little tool called Hey that can just fire off requests. So what we're now doing is that we're running 50 concurrent clients with 10,000 iterations. So what we've now done is that we ran 10,000 requests against my little application here. which took 2.5 seconds. The slowest was 0.05, so basically 50 milliseconds, and the slowest was 12 milliseconds. And you can see here that it's just extremely fast. Granted, it doesn't do anything, but it shows you that the whole Wasm runtime around it doesn't take anything from the performance. It's actually near native. Still, although it's not native application, it's Wasm, but it gets performance that is really great on a near native level. So even if we extend this and say, let's say 250 and 50,000 requests, it will take a bit longer. But still, we should see comparable performance. So that means if you have an application that is triggered a lot of the time, you don't really know, might there be peaks that are really high, you don't really know how much concurrent requests you get, then WebAssembly is something that will help you because it has amazing performance. Again, you can see here, now it's gotten a bit slower, but we have 200 concurrent requests now, or 250, what did I do? Yeah, 250 concurrent requests 50,000 times, and still we are extremely fast. So you can see that the infrastructure, the whole setup is really amazingly fast. But let's actually remove that one again. And show you what I have for the store backend. So the predefined example that I have is just something that uses a key value store that Spin also provides, and it just has an easy handler here that accepts a post request. So if we run a post, it just stores the information. If we run a get, as you can see here, it gets the value from the backend, and we can run a delete to delete something. So again, it's just the WebAssembly application that allows me to store some arbitrary value. And what I want to do is show you how we can integrate this with the customer page in Business Central again. So my AL code looks like this. We have on the customer card an action that just sends a post to my backend. You can see here how an application that is running server-side on Fermion actually looks like. And it will just send a post. That means that the customer is registered. It just creates a record there. And then on after get record of the customer card, we're going to do a get that basically checks whether the customer is already registered in our backend or not. And if we if we don't get an OK, then we get a message that the customer is not registered. Let's see what this looks like. Okay. And we are publishing again, and because we're running in a code space, we have to re-authenticate. Yes. So here we are in Business Central. We open the customer card. It says the customer is not registered. Of course, we didn't send the post request before, so I'll run my register customer. And if I now go back, it shows me that it has registered it. If I change, of course, I'm getting the not registered. Again, this might be maybe more relevant for something like license checking, but what I mainly want to show you is that if we take a look at the performance of loading, you can see my server-side Wasm implementation that has 712 milliseconds. Actually, that's because we ran it twice. Let's go out and back in here. Now we're getting closer to 350, sometimes 300, now it's 400 milliseconds. So we're doing a full backend trip. We're requesting something from the backend. The Wasm application is taking a look at a key value store, returning the value, and all of that only takes 400 milliseconds. Again, should you do that a lot of the time in all of your on-open pages? Definitely not. But if you have a requirement that says, I need to call something in a backend, it needs to be extremely fast, it needs to respond very well, it needs to scale very well, then this could be exactly the kind of application that helps you to implement things. Okay, that was my server-side demo and the whole overview about Wasm. Again, I wanted to show you what is Wasm, where is it coming from, the roots in the browser, now also moving to the server side, moving into IoT and Edge, what are the main applications, and hopefully give you an idea of why it matters for us in the Business Central world as well. So that's it for the first part. Now let's switch into the second part, which is AL on Linux, dev containers, and Codespaces. Why would you even want to do this? The idea of running Linux is that you have something that is completely under your control, you have full transparency, you have full configurability. I used to use a Linux laptop until I moved into the NIV world, and the thing that annoyed me most was that suddenly Windows was doing things and I didn't know what, and it showed me the system process was using 90% of my CPU, and I was, kind of annoyed with it. So that really, from my personal perspective, is the big benefit on Linux. You always know what is happening. If you really want to, you can dig down into the source code and figure out what happens. It has a huge developer-centric open source ecosystem, so I think if you're going to give it a try, after maybe some initial struggles, you will feel right at home. It's definitely less demanding on your hardware, or if you stay on the same hardware, you get better performance. It typically has no license cost, and it's, to be honest, just fun. You can just change it in any way that you want, and Stefan will show you in a second how different it can look. Why would you use AL on Linux? Well, if you're used to the benefits of Linux, if you want to run a Linux laptop or a Linux machine, then why not use AL? If that's the only thing that is blocking you, then we will give you an idea how you can do that. Of course, there's also drawbacks. Sometimes hardware components are not fully supported. Actually, that's also a benefit because it's not coming preloaded with all the drivers for all the components out there. Actually, you need to do a bit of your own setup, and then you can typically make it work. It comes with only very few pre-installed options, so it's not as easy as with Windows to just go into a shop or whatever and say, I want a Linux laptop. You're a bit more limited here. And not everything that you might need for your job will probably work. So things like Microsoft Office, the report designer, of course Windows containers, C-side if you still have to use that, the BC server, although I heard there's a different session that shows you how that might work, and of course the AL extension, but we will give you a fix for that. And if you're into gaming, there are also less options for that. But the most important thing is Linux has a cute logo, so it's a penguin. Who doesn't love penguins? A lot better than just the 4 squares of Windows, so that might be a very good reason to switch to Linux as well. Why doesn't it work out of the box? Of course, Stefan took a look at it, and what also helped a lot here was the migration to .NET Core. So actually, the thing that is running, the code that is running already is independent, but the extension directly used a precompiled Windows binary. Instead, we need to call the generic DLL that is also contained by using .NET directly, and then there were also some small cosmetics in the JSON data types that are different between Windows and Linux that needed to make that he needed to make happen. And the fixing, of course, is done with an extension, which is the AL language Linux patcher. That has very recently appeared on the Visual Studio Code Marketplace. So if you just want to use it, you can find it in the search. And with that, I'll hand it over to Stefan for the first demo.
Thank you. So let's get the screen switched first. Don't be afraid. I'm going to explain everything. It might look different, but it works. All right, so this is my terminal. I'm going to launch a VS Code profile I created. So that should feel a little bit more home already. As you can see, we don't have any extensions installed now, so I'm going to do this live for you. First, we need to have, of course, the AL language extension. And while that installs, oh, it already finished, the Linux patcher as well. So now, only 2 extensions to make it nice and simple. And what we can do now, without patching anything for now, we can do AL Go, we can we have a few commands to open the home. I don't think it worked. I don't want to try it now, but all the other commands like download symbols, debug, publish, all of that's not there. So let's do ALGO first. Just call it BC TechDays. Latest platform. And the generation works, syntax highlighting works. So far, so good. But you didn't see the message pop up that the language server is loading the workspace and everything. And as I said, we can't download symbols. So there is no way we can compile this, actually. It doesn't figure out what build task should be used. So all that doesn't work. That's where the patcher comes into play. And I try to very hard to explain everything you need to do if you want to try this on your own. So precondition is that you have .NET 6 installed on your machine. I included the comments how to do that on a fresh install, and also how you can find where your .NET installation ended up. It should end up in the bin.net folder, and that's the default setting. If it doesn't end up there, then you can change the setting of the extension so it will patch correctly. All right, so let's run the patch. And what happens, it just search and replaces basically inside the AL language extension in the TypeScript code, and then executes the window reload. So you reload all the extensions again. And as you can see, it already asked me to choose a server, which didn't happen before. And I prepared a launch JSON otherwise, so I can delete this. And if I now execute download symbols, which gets available, I can authenticate. And I have my symbols. Almost, not yet. And I know that might not look very impressive, since you can all do this on Windows out of the box right away. But yeah, now you can also do this on Linux. So we can compile without any problem, just Control-Shift-B, as you used to, and we can also publish. Yep, I trust the domain. And there we go. Hello world, published. Everything works. So now a few things that don't work maybe as good. There are still a few things that are not quite there yet. Well, it works on the native machines. I can actually show that. So debugging works as well. I get the full debugged experience here, the debugger experience. So I hope this is big enough. Yeah, it is. So yeah, I think, did I want to show something else? Oh, I think that was it for the first demo.
Exactly. So what we basically now seen, just to put it into perspective again, a Linux host natively running Visual Studio Code, because that just works, and how we can patch the A language through Stefan's extension to make sure that we can actually compile, we can publish, and we can debug as you've seen. Can you switch back to my machine?
Okay. There you go.
Thanks. So that's the starting point. The second idea is, now that we have Linux support, that opens up a whole other world for us. Now we can suddenly start using dev containers and Codespaces, but again, why would you even bother? Why would you want to use dev containers and Codespaces? Well, if we take a look at production environments, we are now SaaS ready. So we have all that automation. We don't need to worry about the whole infrastructure of our production environment. But when it comes to installing our dev side, then it's probably still manual. If you're lucky, then you're working for a company that has kind of a description what you need to do, or you might even have a collection of extensions in VS Code that get rolled out or something like this. But actually, it's still a very manual process of setting up your development environment. And if you're not only doing BC, but maybe different things as well, different programming languages, different frameworks, and so on, that becomes even more complicated. And you probably need to do some manual stuff as well. So the idea is that we run our development environments in a container. And this time, I'm not talking about the container with Business Central and SQL that you probably all know and use. So that's not the thing I want to talk about, but actually we're going to put Visual Studio Code into a container, the AL language into a container, C#, PHP, whatever you want to use, whatever you want to need, whatever you might need for your job, all of that, the development side of it can run in a container as well. That gives you cleanly separated development systems, because you don't have any version conflicts anymore. If you want to develop, and for whatever reason you have to develop with a specific AL language extension version, that can be configured directly in the container. If you have to use a specific C# version, that can be configured in the container. If you need to switch into a different project with a different version, you just spin up a new container that has a different configuration. They both don't interact with each other. They both have side effects. So it's very easy to have different setups for your development in those containers. And I don't know how it is for you, but at least it is for me. At some point of time, my development environment will start to feel slower. Weird things will appear. There's still, then you know that you have to reinstall or start from scratch again. And if you have it containerized, again, that is extremely easy because you just throw away the container, create a new one. It takes literally like 30 seconds, and then you're up and running again with a completely clean, with a completely safe development environment. We have all the dependencies, all the tools, the versions, the other stuff, the settings, the Visual Studio Code extensions that you might want to use. All of that is described in the dev container JSON that I show you in a second. So we have kind of an infrastructure as code approach for development environments. It's completely defined in a JSON file, and we can put it into version control, so you know that your developers are all using the same configurations, they're all using the same setup. If you want to update to a newer version, you just make a change like you would change your source code through a pull request, put it into main, and then roll it out to all of your developers so you know they are running on the latest and greatest version again. And it's an extremely fast setup, so if you need to onboard new developers, if you need to switch between projects, if you have that requirement in your company, it will also help tremendously because you don't need to set up things manually, you just use the tooling, the configuration files, and it's done. How can we do this? Visual Studio Code comes with development containers or dev containers, so they are exactly what we need. Containerized, configurable local development environments. We can connect with Visual Studio Code, so from a tooling perspective, from an IDE perspective, it works exactly the same as if you were working natively, and it gives you the full functionality, including extensions, access to local resources, offline support, so all of that works as you would need it, and really, at least in my opinion, it only has benefits, with the only drawback that it doesn't work Windows-based. So yeah, welcome to the pretty new world where Microsoft is creating tools that only work on Linux. And this is one of the reasons why when Stefan told me that he had made the AL language extension available for Linux, I immediately thought, well, that's nice for people running on Linux, but it actually has bigger implications, and that is that we can finally use dev containers, almost. So the other thing is that it's an ideal starting point for GitHub Codespaces, because Codespaces are behind the scenes using the same technology, and we will see that in a second as well. Now, the basic idea of a dev container is that you have your local environment. So what we're seeing here as the container, that would be your dev container, and you still have on your laptop Visual Studio Code running. So that doesn't change. Visual Studio Code is still running on your laptop. And if you have something like a theme or a UI extension, as you can see here, that is also running on your laptop. But if you have a workspace extension, and the AL language extension is an example of that, then it's actually running in a component that is called VS Code Server, and that is running in the container. So the actual things like a terminal process, like an application, like the debugger, all of that is actually running in the container, which means that we have complete separation. It's not interacting with my processes on my host machine and so on. The only thing that is typically integrated through what is called a volume mount is the source code, so that I'm sure that when the container goes away, I still have the source code on my host machine, so I'm not losing any work. And that's the general setup, how a dev container works. So I spin up the container, VS Code Server is running inside of that. I have Visual Studio Code running regularly on my laptop, and it's connecting through the server component to get development running. And again, we're going to take a look at how that works.
All right, switch back. This is where we left off before. So what I'm going to do is now, to our two extensions we installed before, I'm going to install the remote extensions. There is actually a extension pack with 4 extensions coming bundled. So this is the Windows subsystem for Linux, which we'll see hopefully in a minute. The dev containers, and maybe just let me, yeah, that's maybe better. The dev containers SSH into remote environments and remote tunnels. So there is plenty of stuff. So let's get this installed. And what we can do now is create where is it? At dev container configuration files, and that will guide you through a wizard kind of approach. You first need to choose the template. There are a few templates you can start with. There are Debian dev containers, there are Docker and Docker containers, because that works on Linux. Kubernetes and all sort of things. But what we need to do, because we need to use .NET 6, we can use a pre-built container which has .NET 6. That would be a C# container, but we don't really care. And there we can, now it asks us to select which .NET version we want to use, so that will be .NET 6, so we don't need to install anything anymore. If you would need, for any sort of things, additional features installed directly on container creation, you can choose them here, and that's a pretty extensive list, as you can see. And those also offer you to select the version afterwards, after you selected the modules. But we don't need any for now, so that leaves you with the dev container JSON, and that's added inside the .dev container folder, so it's committed, as Tobias mentioned already, inside the Git repository, so it gets shipped to every developer who clones the directory, so they can start directly right away with the configuration you created. All right, so the image is there already. You can give it a fancy name if you want to. And you can, if you're familiar or just good with JSON typing, you can just type it down here, but you can also change the configuration through the UI. So what I'm going to do is select my extensions, which I want to have added to the dev container to add it to the JSON automatically, and you can see it gets updated on the fly. So we need the AA language extension, and we need the Linux patcher. And as I mentioned before, there is one setting we need. In dev containers, the .NET path is not the same like the default setting I created. So it's not bin.net, it's in the user directory. So that's the only change I need to do here for the settings part. And now I'm ready to go and create my dev container already. So I can just click on this remote icon here down below and say reopen in container. That will reopen my current repository or workspace I'm in, or folder, whatever. Just spin up the container, clone everything in there, mount the folder structure, and reopen VS Code. When you create it the first time, it needs to clone all the images, download them, and build up the whole Docker image and everything. I prepared that already, so we don't get stuck too long. And if you just recreate it from the same image, that's how fast it is. And you can see in the corner down below that it indicates that you're connected to a remote container. And now it's the same story again, like we did before. I don't have any AL commands like the normal ones. I have the folder structure and everything, but I can't execute anything. So I need to run the patch again, because it will now patch inside the dev container, although we have a patched version of the AA language extension already on the host. So it really reinstalls everything in the container as you create it. So
Also worth noting, that's another benefit of having dev containers. If you're doing experimental stuff like Stefan is doing
Yes.
here, you're not breaking your host machine, you're just breaking it in the container.
Yeah,
Not that Stefan is breaking anything, but in case it happens.
Oh, I am. All right. Since I already got the symbols, I can compile right away. And I can also publish from within here. The credentials cache is not shared, so I need to type in my credentials again. And that's the fun. Clear cache. Maybe I just typed it wrong. Better that way. All right. Publish from within the dev container. And now to the debugging part of things. I mentioned earlier that there are some problems still, so I'm going to show you first what works and then what doesn't work. If I go to the onOpen page trigger of the customer card and set a breakpoint here, now start the debugger. You can see that works. That's the part that works. Let me continue, and I will set a breakpoint in my custom code and debug again. That breakpoint still works. That breakpoint doesn't work. So what happens is, at least that's a little bit of my assumption, what happens, that now the VS Code extension, the AL language extension, tries to open up that file, but doesn't look for the file inside the dev container, but outside. And outside at the path it's searching for, /workspace BC TechDays, that path doesn't exist. So we could create the file, but that would just, we would need to create all the files, basically. But there is a workaround for that. And if we have the time, I'm going to show that. So if let me just close that again, close remote connection, and let me copy that over because it's not that easy to type from the top of my mind. BC TechDays, dev container, and I'm going to explain this as well. So what this setting does is basically just telling the remote container that where to mount my workspace folder. So instead of mounting it in the default location, which is /workspace/ whatever it was, it will now use a variable from VS Code, which returns the local workspace folder I have on my host machine and tells the container to mount and copy everything over in the exact same location, which will result in the files having the same path on host and guest. So let me just recreate.
Rebuild.
Rebuild, okay. Rebuild without cache. Rebuild and reopen in container. So now no, it's still there. Do we have the... Oh, probably I need to patch again, since I rebuilt everything. Let's try one more time. Now the debugging works. But there is a huge but to this workaround. It only works if your host is Linux as well. Because otherwise the path layout is different on Windows, and then this just doesn't work.
And by the way, that's a great example for the Linux world. You've probably now seen how snappy, how fast, how responsive Stefan's machine is. I'm pretty envious coming from a Windows world. but then you're happy that debugging in AL works. It's kind of the differences of running on Linux. You have clear benefits, and sometimes you're very happy about things that are just very obvious, but in the end you're happy, so who cares?
All right. So do you want to show the same stuff
Absolutely.
on Windows?
Yeah.
Then let me just
So
publish
Stefan
this
is
to
now
GitHub.
pushing the code to GitHub, so I can use it on my machine, on my Windows machine, and show you how far we can get there.
And I did this from inside the dev container, of course. So it just takes a minute, and then we should... There we go. It's published.
Okay, great. So let's switch back to my machine. Thanks. So if you remember, I told you it doesn't work for Windows containers, and that's true. You can't have a Windows dev container, but what you can do actually is still run it on a Windows host, because fortunately there is the Windows subsystem for Linux, which means that you can run Linux application on Windows by now. It's easiest to install with Docker Desktop, but if you don't want to use Docker Desktop, you can also do it by hand and get to the same point. What's interesting here is that I think some of you remember this nice guy who said Linux is a cancer, but fortunately Microsoft has absolutely changed direction here. You probably also know that guy, and they decided, well, actually Linux makes a ton of sense. I don't know the current numbers, but until very recently, the amount of workload on Azure, for example, was dominantly Linux-based, so it was almost 50-50, but actually there were more Linux workloads running on Azure than Windows. And I think that kind of gave a push into the direction that maybe it makes sense to invest more on Linux as well. And one of the things that we can see on the client side is the Windows subsystem for Linux that we can use to get that done. How does that look like? And now this is the demo that I'm actually scared of, because just before we started, Docker Desktop had an update. And I don't want to comment on any way on what that means, but we might have an issue. Let's see. So the first step is a git clone from GitHub. And we have Stefan's BC TechDays. And that should be it, right?
Yes, TechDays.
So let's clone this here. And it's hopefully cloning. Yes. And I absolutely want to open the clone repository. And now you can see we have the same dev container JSON with the same configuration that Stefan showed us before. Those settings don't work, so I'll remove them. And Visual Studio Code immediately recognized, well, you have a dev container configuration file you might want to develop in a container, and you also have the Windows subsystem for Linux, so it actually might work. And now we are restarting. We are starting the dev container, and it actually might work. And I'm only surprised because it was the Docker Desktop update. Otherwise, I would fully expect it. Yes, indeed. You can now see that we have the full configuration set up. Let's do something like this to show you that it's coming from a different backend. Of course, this is now my dev container, so I also need to patch. And as you can also see here, the AL language Linux patcher is already installed. Actually a bit surprised why the AL language isn't, but...
Sometimes because it's a little bit bigger, that extension, it just takes a moment. So sometimes the reload window, I experienced this before, sometimes the reload window just did the trick.
Okay.
So.
But anyway, now we should have it in the dev container. Yes, I run the Linux patcher on my Windows host. And it restarts. And we should hopefully see it loading.
I have the impression it was a little bit faster on my machine. Now I see.
That's just because your laptop is so much faster.
Yeah, probably.
So we have it up and running, and let's see if the extension works. It's loading the workspace. That looks good. And when it's done, let's try to debug.
And what we have seen before when Tobias showed his first demos, where he would need to authenticate all the time, there seems to be some kind of issue with the caching for the device authentication. So what we did for those demos was actually to use an Alpaca container where we can use username and password authentication, because that gets saved correctly, so we wouldn't need to re-authenticate all the time.
Okay, so here we have it, and just to reiterate, this is now a Linux dev container running on my Windows host with the patch AL extension, and I can use it to do deployment. So actually the whole dev container story, if you felt like, well, that sounds interesting, but unfortunately I'm stuck on my Windows laptop, you're not really stuck. You can just give it a try using the AL language packager. You need to have the Windows subsystem for Linux, and then it should immediately work for you as well. Okay, so this is dev containers. Now, what is GitHub Codespaces? As I said, that's basically the logical next step if you are already on dev containers. If you started with that, then using Codespaces totally makes sense. And the reason for that is that it's basically doing the same thing. So if you remember the picture of before, we had a container with a clone of the repository, with the workspace extensions, with the tooling, and so on. So basically, the green thing in the middle is exactly the same thing as we've seen before. It's a Linux-based dev container. The only difference is that this is now running in a virtual machine that is running on Azure. So this is no longer on your laptop, no longer on your virtual machine or wherever you're running this, but this is just a fully managed service provided by GitHub that is running somewhere in Azure. And then you can connect to it, same as we've seen before, using VS Code Desktop, but you can also use it in a browser. That is where I did my Wasm demos. You've seen it all in the browser. That's basically GitHub Codespaces. So that is what we've used here. And if you're into JetBrains or want to use a command line, that also works. But again, it's the same concept. It's the same basic idea that you have there. It's just that the container is running somewhere else and not on your machine. To give you an idea of how well this works, GitHub has completely switched their own development into Codespaces, I think 1.5 years ago. So basically, GitHub is completely developed in GitHub Codespaces. So it's absolutely a very scalable, very performant, very highly available environment that you can use for your development, with the shortcomings that we've seen in the AL language extension. But for non-AL, or if you can live with the restrictions that we've seen, then it's a really great way to work and not be reliant on your local hardware anymore. But how does it look like?
Demo time again. There we go. All right, so I pulled up that repository on GitHub, and since Codespaces make use of the same configuration we used for dev containers before, we can just start right away and click on code, and instead of cloning it locally to my machine, I will just select the Codespace section and click create a new one. And it will create the same Docker container, basically. The same images will pull in the same settings.
Sometimes it needs to re-pull images, and we're lucky enough that we can now watch downloading container image layers. But fortunately, the base image is quite small, so if I keep talking for maybe 10 more seconds, then we should be done. But you can definitely now see it's the same base technology. It's creating the container like you would create locally, just hopefully a bit faster. And now I'm done speaking.
All right, there we are. I hear that it's better to demo on light layouts, so let me just switch to something more bright. And now same configuration in here. The extensions are installing, so we need to give that a little bit more time. But those Codespace dev containers, they are not recreated every time, so you can actually reuse them. That would speed up things a little bit if you need to hop between repositories a lot.
And it's on-demand pricing as always in the cloud, so while it runs, you pay for it. I think they have something like 50 hours for free every month, and then it has an auto timeout, so if you're not doing anything for half an hour, then your code space is automatically stopped.
Yep. All right, so need to patch again. And since good practice, I committed all the symbols and everything into the repository, I can build right away. And there are different kind of sizes for those code spaces. I'm probably running on the smallest one possible, so that's why it's a little bit slower right now. I think it's a 2-core machine or something with 2 GB of RAM. So yeah, but as you can see, it does work, and I can publish from here as well, of course. No, I don't want to save that. And there we go. Same limitations for debugging, unfortunately. So although I have that fix still in place, it only works if I'm running on my machine, on my dev container. So if I'm running in the browser and with Codespaces, it unfortunately doesn't work. It doesn't fix the debugging.
As you can see, it's not fixed. That's interesting.
Wait a second. I switched demos in between. No, I switched back to my local VS Code. That's why it worked. I mean, that would have been a fast response time from Microsoft.
Yeah, that would have been very impressive, actually.
So let me just debug from here again one more time.
But it's, I mean, I didn't notice, you didn't notice. We could have gone away.
All right, so here, that's the error I wanted to show you. Pretty cryptic, but it just tells you that the file isn't found because it just doesn't search inside the container, but outside. So yeah, that's it. But I think the use cases isn't really doing much of like real-time or all your daily development in a code space, right? So rather than just, if you need to do a quick fix on a pull request or anything, you can just spin up that code space, do the fix, because you have language support, you can publish this, you just can't debug. But yeah, for quick things, because the VS Code inside the browser, when you just switch the domain from github.com to github.dev, the A language extension does not work because it needs to have the language server components under the hood and everything. So Codespaces is the way to go. There it works.
Absolutely. And I personally started with Codespaces with the same mindset. Yeah, I'm probably not going to do all my coding there. I'll just use it for maybe a pull request review or taking a look at a bug or whatever. And by now, I'm happily using Codespaces for a lot of scenarios where I don't want to worry about stuff locally. Typically things that I don't need every day, but maybe once in a week or once in a month, I just have a Codespace configuration. When I need it, I go there, Codespace, start it, wait for a minute, and then I'm up and running. And for that, I find it very, very easy to use. And I've done development for full days in Codespaces. That absolutely works as well.
But just to mention it once more, all those drawbacks and all those things that don't work are limited to Codespaces or dev containers. If you're running native on Linux, it does work. I work like this for several months now, and apart from a few extensions which are not yet supported, the A language extension works. So I'm working like this. It does work. So
perfect. So let's switch back to the presentation, please. Thanks. Yeah, so that's what we've seen, the GitHub Codespaces setup. But maybe the question you have is, well, I'm actually still running on Azure DevOps repos, and I personally don't plan on switching. We all know there are great options for CI/CD on GitHub as well, but if you have invested there on Azure DevOps with ALOps or Alpaca or your own homegrown solution, whatever, you might still want to stay there. So does that work as well? Can I use my Azure DevOps repository inside of a Codespace? And the answer, fortunately, is yes. The only thing we need is a dev container feature, and that's an interesting mechanism that I also wanted to show you. This is basically an excerpt of the same configuration file that we've seen before, where Stefan did the changes. And there you can do something like features, which just adds something pre-configured into your dev container. And we have a specific feature here called external repository. The background of that is that there was someone in a Microsoft team that absolutely wanted to use dev containers as well, but was stuck on Azure DevOps repository, and that guy created that feature here. So what it does is you give it a clone URL, and you can see here that it's coming from an Azure DevOps repository. It needs a secret. Actually, the guy told me that it doesn't need it, but I haven't figured out how that works. And then I have a folder that tells me where it should clone it. And you can find the repository here. And as we have a bit more time, I'll also show you. So again, we're now in GitHub. As you can see, the repository only contains a dev container configuration. But if I do go into my dev container that is connected here, I do get completely different code. I have a customer list extension page. I have, again, my pre-patched extension. So it's loading the workspace. And I can work on it. And just to show you, if I go into the remotes here, you can see there's an Azure DevOps remote in my dev container. So I have my Azure DevOps demo Codespaces repository with my customer list extension with a hello world. And now I can work with it like I would used to. So let's do a BC TechDays again. Do a commit here. Push it. Yes. And if we go in here, in Azure DevOps, you can see the change that we expect. So as you can see here, using that configuration setting, I can also use Codespaces connected to an Azure DevOps repository. You have that somewhat weird in-between repository on GitHub that you need to create that knows which Azure DevOps repository is connected. So the setup isn't as easy as Stefan has shown you. You need to create the dev container file and put in the right configuration options. But if I find the time, maybe in the train back, I'll also try to create a Visual Studio Code extension that does this for you. So then you would be able to very easily spin up your Codespace connected to an Azure DevOps repository. Okay, that brings us into Q&A. So thanks a lot for listening. Any questions from your side? Yeah. Thanks.
Can we scale up and scale down the Codespaces as we want?
Or yes. You want to show, or
show you? Go back into the Codespaces. If I go to Manage Codespaces, then I can see here that it's now a 2-core machine. And then I can say change machine type, and that gives me additional options. I can click on it, wait for typically half a minute, and then I have the new resources on my Codespace. Further questions?
Hello.
Hi.
So a question about Wasm. A couple years back, I did some experimentation on publishing the Wasm into Business Central, and I ran into a problem where BC Server would refuse to publish the Wasm file if it was under .wasm, right? So I was wondering if, since obviously in your demo you did exactly that, So I was wondering if that is something that was recently changed or if that is just a server configuration issue.
To be honest, I've been playing around with Wasm only on the server side, and only for this presentation did I try the client-side BC integration. So the first time I tried this was like half a year ago when I handed in the session and wanted to be sure that it actually has a chance of working. So I can't comment on anything before half a year ago. I can only tell you that it seems to work by now.
I see. Thank you.
Okay. Further questions? Yeah, up there. Stefan? Let's see. Yay.
Yeah, I had a question regarding the patcher. It's actually two small ones. First, is the patcher open source one? So can we see what kind of magic you're doing? And a second one, is there an option to have this patching as a step when you generating your dev container? So why should we have a kind of separate patching?
Yep.
Good idea.
Well, it is open source. It is on GitHub. I already opened it up because if there wouldn't be any questions, I would have shown all the details. But you can look it up yourself. It's on my GitHub. It's linked within VS Code, so you can open it up directly. And the reason why I did this with an action was basically because it was like a workaround or a quick thing just to get me started around. But if you want to, feel free to do pull request, change it around so it happens automatically. Would help me, would help others, so would be possible, I think.
Yeah. In dev containers, you have a configuration that is called, I think, on-post create command. So after it's created, you can run some code. That would be very easy to patch the L extension there, but that then again only works in dev containers. If you're running natively on Linux as Stefan is, then you would need a different solution. But yeah, certainly doable.
For me, it was the easiest way to get around possible situations where the AI language extension is not yet loaded correctly. I can issue the reload afterwards, and it's just one click. So it was easiest solution for me.
Further questions over there? Full disclosure, no more shirts, so only ask the question if you're really interested.
Yeah. You used alpaca containers for your demos here. Does it also work with if you have your BC running in a local container?
Absolutely. Yeah. The interesting thing if you're running in a Codespace is that it can also access local resources because your VS Code might be local. So depending on what exactly you need, that could be possible. If the server-side process needs to publish, then the container needs to be available publicly. So if it's basically the AL code that's running somewhere on Azure, it won't have a direct way to access your local container, so you might have to think about the networking, but otherwise no technical limitations. Other questions? Down there.
Hi, thanks for the presentation. Did you try other flavors of, you mentioned like Windows and Linux, but I'm wondering about Android or iOS, or trying this out on a tablet, or no?
I did not try. I mean, I'm pretty confident that all of the Linux flavors work, but beyond that, I don't know. I don't know.
And Codespaces is just browser, so I've used that on my Android phone, and I'm pretty sure it works on an iPad or an iPhone as well. Yeah. Okay. Other questions? I don't think so.
There at the top.
At the top. Oh. Letting an old man run. Can you raise your hand again, please? Ah, over there. Thanks.
Regarding the branches, so Azure Git repositories, can we somehow download multiple of them? Because we have a dependencies of apps, you know, is it possible to just set them up there in futures, or can we maybe run some PowerShell stuff?
that would, I think there's no setting to have multiple repositories,
Yeah.
but you could easily run a PowerShell script
Yeah.
to pull them as well. And the source code of the extension or of the feature actually is surprisingly easy and trivial. So if you need that, I think it would not be a lot of work to just extend it.
Yeah, thank you.
Further questions? No.
Doesn't look like.
How are we on time, Stefan?
6 more minutes.
6 more minutes. Do you want to show the Linux Patcher internals?
Yes.
Who wants to see the Linux Patcher internals? Okay,
There are
so
a
go
few.
ahead.
All right. So as I said already, this is on GitHub. You can have a look yourself as well. You can do pull requests if you feel like there's missing anything or if you would like to see some other features. But what it comes down to is basically just one command, which get executed, and I added some code comments here, and I hope this is big enough. It's a lot of code, a lot of path, because what I'm doing is I'm reading. Basically, I'm getting the AL language extension base path. Where do I get it? There. So I check if there is the MS Dynamics SMB AL extension, which is the AL language extension. If that's installed, I get the path. So it's independent where you're running this. It works for VS Code configurations. If you have different path, it all works. And then inside there I open up the extension.js file and just do a search and replace of those two things. So there you can see that what Microsoft does is, let me just see if I can find it. It gets the server path from another function, which will return the path to the actual executable, the .exe on Windows. And to make it work on Linux, I need to change that. So first parameter needs to be, let me see.
Maybe you want to open vscode.dev so you can switch to light.
I try to highlight what I'm talking about.
Good.
So you can see. So what I'm doing is I'm inserting the .NET executable on Linux, and then at the first parameter I set the path not to the exe but more to the DLL of the editor services host. So that will basically run, instead of the exe on Windows, it will run the DLL because of .NET Core with help of that configuration. And that needs to happen in 2 places, and I try to make it as dynamic as possible. So the the .NET path is a setting, and the path where to find those DLLs and where to replace that's read live on runtime. And then just some cosmetics. There are a few 2 JSON files, the ALC runtime JSON and the according JSON file from the service host, which just need a few settings. It says included frameworks, and I need to change it to framework. And that's all that happens. So those files get patched, those 3 files, and then I issue a reload window. And that message I tried to display doesn't get through because of the reload window, unfortunately. So yeah. And I hope that those lines I search and replace don't change too much, so I don't need to update my code. But as I said, I'm working with this on a daily basis, so I'm probably the first one who noticed, and I will probably update it if it breaks. But yeah, that's all there is to show. So it's not that complicated.
Perfect. So again, thanks a lot for joining. Enjoy the rest of the conference.